Ladies and gentlemen, my name is Asim Zafir, and I will be today discussing the use case about Open Policy Agent and how it's applied in cloud native environment, cloud native distributed environment. I have a case study to share with you. Play the hand type, please. um, to get started, I just want to explain that how this open polyasync is actually working. So it's actually the way the open policy. So by implementing the open policy agent layer in the architecture, you're basically decoupling the policy enforcement with the actual deployment configs and all the other overhead that comes with it. So you can think of you're basically decoupling every aspect of the policy management and enforcement, and as well as open policy agent can also act as a very efficient RBAC and roles-based management or ABAC management layer. And one other benefits of that is also going to be providing everything in a one stack solution. So it has a centralized way of maintaining all the policy enforcement, as well as it can be very efficient in maintaining the audits for the particular environment or infrastructure of an organization that spans over several departments. You don't need enormous amount of resources or various policy management interfaces to manage those for every different infrastructure. It can be a centralized stack to manage all that. So to get to the topic, I have a use case here where basically I want to basically discuss a use case. So the entire idea gets inspired that how to actually manage policies. I mean, it can handle policies outside the space of cloud native as well. But one of the biggest problem that OPA actually solves is about it solves the latency problem. And because in the cloud native space, because most of the interaction, one of the biggest backlog of the centralized policy management in a cloud in a SaaS environment would be enormous amount of latency that can slow down at the admission control, can pretty much cause bad user experience, and also so it has to be distributed and scalable, and as well as the latency needs to be latency problem needs to be solved, and for that reason. So it's getting it's predominantly solving the problem for the cloud native space, and it fits well with the every variants of the Kubernetes stack. So in this example, I'm showing you that how can you do that. So there are few implementation strategies. So there are a few things here, right? So there is a nature of policies that are very strictly tied to admission control, and the other could be like, okay, authorization related policies, and also some policies are very some controls that OPA can basically bring on the table is very granular type of mm, RBAC or authorization. I mean, very granular level of role-based management or authorization-based AVAC type of solutions, and that becomes very granular after the admission control, as far as the life cycle of Kubernetes is concerned, you can control that with open policy as well. For example, if you want to, uh, if you have a situation in your infrastructure where your Kubernetes stack is going through some type of upgrade or let's say maintenance where 50% of your nodes are cordoned off, you probably don't want to carry out a deployment. So you would like to block the deployment uh, if such situation is taking place. So that type of granular control would be that use case is after the admission and it is directly connected to the state of the Kubernetes stack. So we don't generally that will not be an admission control policy, but it can be a policy that is specific to um, a type of Kubernetes object like pod service or ingress controller or something. And we with gatekeeper the open policy agent the latest versions gives you an ability to integrate the rego policies in the crds that can but there has to be an external way of fetching the state of the cluster because the open policy gatekeeper doesn't have a way to sync the real-time sync of the state of the cluster. So it has to be an external effort to actually fetch the state and then pass that state to open policy agent uh, policy. So it's basically going to be a black box. So you fetch the state of the cluster. So let's say this is the state of the cluster that you're fetching through an external means. Um, so you're fetching the state of the cluster through the external means, and you're fetching the cluster. This is recording, sharing. Let me see. Okay, I'm sharing the right screen. Sorry. So yeah. So let's say we have a state of the cluster. So the gatekeeper doesn't have a way to sort of open policy. Gatekeeper doesn't have a way to sync to the state. So let's say this was the state of the cluster. If this was the state of the K8s cluster, this it's a stateless environment, right? So it doesn't have a real-time sync of the state. So you don't really have a stateless. It doesn't have a real-time sync. So what you do, you use an external way. If you so create a script or something, basically to fetch the state of the Kubernetes state, like you actually do a fetch, do a state of um, you actually do a fetch, right? So sorry, you fetch the state of the cluster. So, so what does that mean? So fetch the state of cluster means let's say you are trying to look for how many quarter nodes are there. So basically you have to see that how many nodes are basically is in not ready state. So you can create a script and you can say um, get nodes and then for example and just see that how many of them are not ready, right? So that will tell you, okay, certain percent of this. So let's say you do a fusion that will give you how many nodes are not ready. Then this minus count, so you carry that out into a variable. So let's say you store that whatever that count is. You basically predominantly what you do is actually you have to um, carry that out and then basically you carry uh, a count of how many nodes are not ready and then and basically do a subtraction with the total number of nodes. And I'm just saying, so you can say, okay, if this count is if this count total number of nodes, if this count is greater than zero or something, basically, like you can say that if some nodes are not in service, and you want to basically invoke a policy here to say that I don't want any API calls. I want to basically block, right? I want to block everything that basically using API call to apply a manifest or something, right? So you want to block groups API calls to deploy a manifest. So um, this type of external granular state cannot be synced with. So you need to write an external script that fetches the state and then basically pass through the Rego policies, right? And Rego policies will either allow or deny. So basically, there are two outcomes to it. There's a deny. There could be, it could be either allow or deny, right? Allow or deny. So, and the default, everything is false. The state of the allow is the allow state is always false. And in Kubernetes state, um, everything is allowed except you deny it. So most of the policies should look like a deny rules. So that's how it works. So in the demo, I'll show you that how the repo I've created, like how I've segregated. So this is all about policy management, right? And the art is to basically come up with security policy. So the art is not, the art doesn't, when Rego and OPA are tools, but I think it will only make sense if you know how cloud security works and cloud infrastructure actually works and what type of policy you can come and design it so it can be very effective. So you potentially need to be very familiar with if you're dealing with OPA, you want to take benefit of OPA, you should know about cloud native very well and have worked in this environment and you understand the security challenges and can differ between what are the admission controls, what's authorization, and we are not talking about authentication here because authentication is not something OPA handles. And also, after admission control, if you want to control further life cycle of operations of the Kubernetes cluster or AKS cluster or anything that's cloud native, you can do it through granular policy controls by deploying CRDs. And within CRDs, you will have a policy code that integrated. So having said that, I'm setting the context. Hope this is clear. You can ask me any questions. It's fairly, so I have a sort of a design here that I'll explain you what it's doing. So I have three environments here, which is called dev, prod, and QA. And so we have a little bit of components here. So we have a credential management. So anything which is non-cloud native, anything that has nothing to do with admission, any credential that allows the access to the cloud native ecosystems, like for example, AWS keys or tokens or something, which basically particularly related to admission into the compute infrastructure. Um, any anything that's not related to that is an external credentials like some type of API access key for some external service, or let's say SQL database passwords, or anything that has nothing to do with cloud native admissions can be stored in a vault credential management, or anything that is related to Docker runtime, which actually is running in your CI/CD engine, like on runners or something, that you would repeatedly would need those credentials for making a session. That could go into the GitLab or any CI tools vault system, because the benefit of that is that you can inherit those variables quite easily in your CI code. So hope that's making. That's why I have these two categories here for credential management. In this case, I have a very generic type of architecture where we have a elastic load balancer. Probably this has a public IP interface where folks are basically connecting to it, so public IP interface. So IP, you do SSL handshake, whatever you want to do here. Resolvable. That's what the world knows, and everything inside will be all private infrastructure, right? So in this case, you have this. Similarly, you have prod, and I mean, I guess I made a dev environment, but let's say uh, somehow, I mean, dev access should not be given to anybody in public, but let's say the ELB actually faces an access to, it could be intra service, like, where you are giving an application service access for validation or something to your internal customers. So you can say intra public, intra office, intra dev environment, which is publicly accessible, right? So that, I mean, basically, what I'm trying to say is that this layer, ELB layer, is actually doing a resolution of it's the entry point, and if this is a publicly served application, the public IP and SSL handshake is happening here. That's the whole idea, and everything internal is that's where we don't do SSL offload or something, and it's basically directly going to the ingress controller, and then it's going to the services object services layer. So you're actually from here onwards, it's all cloud native space, right? Basically, downwards. So this is all cloud native, but these ELBs could be AWS or any Azure, gateway application, um, API gateway or something. I mean, basically that's the ELB there, which is actually giving you access to come inside and basically do proxy pass into Ingress controller and then the cloud interface. So in this design, as you see, this is the Ingress controller, this is a services layer, and this is a deployment object. And under deployment object, we have pods. And let's say you have 10 pods per deployment object, and every pod. So the benefit of these the OPA policy agent in this format, and I mean, in this architecture is actually acting as a sidecar. So it's OPA sidecar, and this sidecar is deployed across whenever the manifest of the pod manifest is getting deployed or deployment manifest is deploying. This is basically acting as a sidecar, right? So that sidecar manifest is attached to the deployment object, and it's universal. So if you're deploying a deployment object and it has a replica set of 10, and so if let's say this is application pod, so it's decoupled, all the policies they basically decoupled, and the policy all the policies are basically tied to an additional sidecar, which basically sits along with on this pod itself. So it will be part of the pod manifest, the deployment manifest. So it's universal, right? So it goes and applies to all the manifest. So that's how, and the benefit of that is why you want to do this, to make it scalable and to reduce the latency. The latency is dropped to probably very low latency. You're probably talking about nanoseconds or even less. Maybe very low. If the infrastructure is really fine-tuned, we can be going very low numbers on milliseconds or probably nanoseconds. So the latency is pretty fast when it's acting as a sidecar. So OPA can be deployed, if not as a gatekeeper, it can, when deployed as sidecar, the deployment on the Kubernetes or anything Kubernetes is deployed in a fashion of a sidecar, and that's where the OPA policy agent is actually the OPA logic that's basically taking care of the policy management. So it's policy enforcement management is taking place by this. So this is the compute logic, and it's acting as a sidecar in this deployment. So that was the whole idea, to show you that. And I have a repo that I will share it with you, but pretty much what I am going to show you is that to implement these, how these policies can be implemented and what it actually means. I can show you created a. Yeah, I'm just having a problem seeing what I'm sharing. Let's see. So, what am I sharing? Let's see what I'm sharing. Okay, so I have to move the screen. 1 second. Let's see. This is a second screen. Switch toggle screen. Let's see. Okay. So, for the purpose of this case study, we have a policy enforcer, and we have two environments. In this case, I am actually doing it for the Azure environment, and so we have the code repository looks like this. So you will have a gatekeeper logic, which basically is doing admission control, and SCAR is sidecar, which actually is doing in-depth discrete level of lifecycle management and discrete policy enforcement uh, on the runtime, the Kubernetes runtime. So that's admission control and that. And for that, um, the idea looks like this, right? So for example, for the gatekeeper logic, it's more like admission control. And it goes, I mean, the object that basically you have to create is a constraint template, and it's deployed as a CRD, right? So that's the logic. And the API references this, and the main object is that these gatekeeper logics are imposed through CRD templates, and the CRD templates has a regular logic here, which actually is saying that allowed registries are only this. So if there's any other registry which is not part matching this, basically you will have to, I mean, it will not allow the admission to it, right? So it's mostly have a deny logic. So like it will deny um, container orchestration should these constraints are true, right? And everything within this snippet is an AND logic, and it's actually has to be true. If this is true, we will enforce a deny, and we'll enforce this message in the runtime. Okay. So these are admission control policies that I'm just sharing with you. So some of the examples are like deny host path, right? So the other is like, okay, what type of admission logic is cares allowed registries. Right? These are pre-admission type of policies that needs to be checked. Deny the latest, deny latest. So if you have a tag, that the latest tag on a repo, just deny it. And so that logic is, so that's not happening. That's happening behind before the admission into the, so anything that basically does talks to the API gateway, Kubernetes API gateway, and beneath is basically not part of this logic. Deny privileged. So basically, this is the time where all the manifests and repos being analyzed, and the manifests analyzed, and if any one of those things matches this basically gatekeeper will block it, right? So similarly, the sidecar logic goes like this, right? The sidecar logic will say that deny container as a root, right? So if the manifest type is pod and container is spec containers and security concept is not as a root, you can't actually execute any API call on it, right? So, as I told you about the if you don't want to allow um, API calls on a Kubernetes cluster that has about 30% of nodes that are basically port on. That will be a logic that can go into the sidecar. And the sidecar Rego policies uh, will be that will be after admission. So that will be the use case for this. And so this is what, and for example, this logic is saying, okay, if, for example, post network usage, right? If uh, if the host network is true, if there's a particular network you don't want to be connected on, and if that criteria is true, the message that will be denied, but the message that will be received by it is going to be the message use of the host network is forbidden. That will be displayed only when the API call will be made. Similarly, this package actually needs to go up. So there are security packages. So they have a bunch of security packages that so you can so that package admission block terminal access in this case. So example, deny adding any capabilities or host network usage, or for example, in this case, terminal access. These type of uh, policy enforcements are happening after admission, and so that will be taken care of by this. This is perfect for the sidecar logic. Anything that you that needs to be done at the application runtime when the resources are deployed and changes are being applied after they're deployed, right? Those things can be the gateway for the sidecar logic fits where, because it's actually managing every aspect of policy that I showed you earlier. Let me show you. So anything that is actually taking care of uh, the when the application is deployed in the runtime, and any changes or any updates or state changes that needs to be done, and that policies before you applying those changes, the sidecar will that these policies, the sidecar policies will be effective. But pre-admission, gatekeepers are efficient for that. So I have a little summary to share. Um, so the scope authorization and admission control is used as an action, right? Admission control, K8s is going to be related to pods, object, uh, K8s API server, right? Authorization, anything API, service, app, external codes. So the authorization piece, the admission control, authorization piece or authorization of permission, this goes into the sidecar logic, and this goes into the admission control piece is basically pre-admission is going onto the it's going onto the gatekeeper implementation, the gatekeeper stack. I hope it is I have explained myself well. Should you have any questions, let me know. Thank you very much for your time, and looking forward to connect with you. Thank you. Bye.